So, welcome again. And there's a disadvantage of being short. Many of you will not be able to see me, but I'm you're, you'll see my slides. So today I decided to talk about pandemics reshaping the future because I thought that's a very interesting topic. And among the numerous challenges that humans have faced over eons of time are infectious diseases. And actually, with over the last few decades, we know that rather than infectious pathogens, we have good pathogens inside us, in the gut, in other parts of the body. So our personalities, what we do, and how we carry ourselves is actually decided, or the actions of these good bacteria and pathogenic bacteria. So we have a history of pandemics. It has occurred many times in the past, and I can start in the beginning, sort of, that a group of apes some 6 million years ago actually evolved to become the species Homo. So there were about 9 species of Homo, and some of the subspecies, of which my pointer is not working, so or you can't see it here. So the Homo sapiens is the only one which survived till today. So that is the smartest species. And microbial life appeared about 3.7 billion years ago. So when organisms came on Earth, the microbial organisms started infecting, and they also evolved along with all the organisms, including the humans. So this is not working actually. Huh? It's not working. It's not changing the slide. It's changed? Okay. The human and pathogen coevolution occurred during the course of evolution for millions of years. And by coevolution, what we mean is that when two or more organisms are staying together, so under selective pressure of evolution, they change from good or worse as per the need of itself or need of the others. So there has been a tussle between the host organism and the pathogenic organism, because selective forces are acting on the host to eliminate the infection and acting on the pathogen to infect the host. So in this constant tussle, our immune system has evolved as it is today. So when the original humans came out of sub-Saharan Africa, the place of origin of humans, they radiated all over the earth in all impossible places. And as you know, the recent Nobel Prize, which Svante Pavo had described, that there were Neanderthals, there were Denisovans. So that those came out of Africa around 200 to 300,000 years ago. And then in about the Homo sapiens finally ruled the earth, and it's in all over there. And so as the humans migrated to different places, the pathogens also evolved with them according to the environmental conditions that the humans habitated. Now, in the very early times when humans were only hunter-gatherers, they were staying in small communities, so the spread of the disease was very low. But when they started making villages like this and started domesticating animals, they started more and more humans started making communities. And that's when because the groups were living in close proximity, and agriculture facilitated the emergence of plant viruses, domestication of animals had a close contact between the humans and the animals, and then species jump of pathogens was possible from humans, from animals to humans, and pathogens from the meat of hunted animals was another issue, because that is still happening when in Africa their bush meat is taken in. So in the in the history, you can see that many of these pandemics that has happened. First was the plague of the Justinian. That is the first recorded history. It killed about 50 million people. Then Black Death or plague that killed about 200 million people. And then others, the New World smallpox. Smallpox did not kill only 55 million. It killed about 300 million people. And then the third plague occurred in England. And now we are living through two pandemics, HIV and COVID-19. But the Spanish flu, with which the COVID-19 is mostly compared, killed about 100 million people. So that was a very devastating pandemic. Now I will say something about the smallpox, because smallpox is the one which actually changed. Because of smallpox, there were not a lot of vaccines developed. So genetic evidence actually suggests, yes, thank you, suggests that the smallpox virus emerged about 3,000 to 4,000 years ago, because in the in the Egyptian mummies, you can find the mummies with scars of smallpox. And during the 20th century, it is estimated that smallpox was responsible for 300 to 500 million deaths. It had a major impact on world history. Where indigenous population of regions were not exposed to smallpox virus, smallpox invaded much of the population, such as America and Australia. And the population was reduced by smallpox during the periods of initial foreign contact, which helped to pave the way for conquest of colonization. One example I'll show you. There were three very well-developed civilizations: the Aztec, the Inca, and the Maya. And you can see it in around the South American part of the land. And all these three civilizations were wiped out, because most of the civilization was wiped out when Francisco Pizarro actually invaded, and he crossed across the peninsula. And what happened was, in his ships, he had only one slave who had smallpox. And that one incidence actually spread to the native population, because their immune systems were naive. They were never exposed to smallpox virus, but the Europeans were exposed to smallpox virus. So that helped in the conquest when most of the native people died. So this is how smallpox has actually altered the history of human civilization. Now, Edward Jenner, the name is very familiar to all of us, was a British physician who is actually called the father of immunology, which is that he actually put a scientific connotation to the smallpox vaccine, because variolation was a process by which smallpox pustules were taken and injected in humans so that they evolved the immunity. But lot of catastrophic deaths were there because of such inoculations, because they were live smallpox viruses. So Edward Jenner, in his observations, found that people who handled cows, so they were exposed to cowpox. When they were exposed to cowpox, that cowpox virus provided some kind of immunity to the humans. So he took the cowpox and injected. This is a etching from the Batman archive, that he is injecting a little boy, Phipps, with cowpox virus. And he later challenged this boy with these actual smallpox-infested pustules, and this boy survived. So his work represented the first scientific attempt to control an infectious disease by the use of vaccination. So he actually did not discover this process. It was for many years, it was in China, it was in India that this variolation process was being carried out. But he did actually give it a scientific thought. So the smallpox is, after his vaccination, after he discovered this vaccination, there was a massive vaccination campaign going all over the world. And for the vaccination, what happens is that the two kinds of cells, the dendritic cells and the macrophages of our immune system, actually sees the virus, chews it up, presents its parts on the surface, and is communicated to the helper T cell, which actually tells the B cell to make the antibody. So that is the basis of vaccination. So I didn't go into very much detail in here because this is a very, very complicated process, and if you look at the macro level, it's really very complicated. But in a nutshell, that helper T cell has to be activated to tell the B cell, who makes the memory cells. So in future, if any infection is there, the memory B cells would come in, make plasma cells, and make antibodies. So that his vaccination then, the vaccination then can provide herd immunity. By herd immunity, I mean that most of the population is vaccinated, or most of the population is immune by exposure to the natural antigen. So if you look at the first cartoon, you see that all the blue ones are the non-infected. So the red ones are spreading infection. It can spread to so many people. But if a population is vaccinated, it is immune, and the non-infected ones also has a lesser chance of getting infected through because the herd surrounding people are all immune. So this is how the smallpox vaccination worked, and it was very effective. So this, because of several systems, the surveillance, identification, reporting of smallpox cases, reward system, that people were giving rewards if they could identify smallpox cases, and then analysis of the data and the containment in the villages worked. So finally, in 1980, World Health Organization declared that smallpox is dead, which means that this is the first example of an infectious disease that we have been able to eliminate from the face of Earth. So, there are two designated sites where stocks of variola virus are stored for use in research. One is CDC in Atlanta, and the other is in Russia, because this is a potential biological weapon. Because if it gets out and infects population, you saw what happened to the Mayan civilization and the Aztec and the Incas. So it can work like that. So there are reference vials which are kept so that if necessary, vaccines can be immediately made, and actions can be taken. So there are two in the world. There are two places that they're there. Now coming back to the first plague, the plague of the Justinian, which killed 50 million people. This is the first recorded history of plague, and the 6th century plague, this one, is the earliest one. So even before that, there was one other pandemic, but the records are not available, and one is not sure that what it was actually. So this plague actually came to Constantinople, the capital of the Eastern Roman Empire, in 542. And as many as 10,000 people per day perished, and people ascribed the plague as the will of God, as was the situation then. So this plague actually marked a turning point in the development from a culture of Roman conventions of the past to a civilization turning to Greek character in next 900 years. So this, any pandemic, out of crisis, many things come out. So this marked a change in the culture of the Roman, going from Roman conventions to the Greek. So if you look at the incidences of plague, that from about 6th century they are coming, and until it continued till about 17th century, after which it went down. These are the many incidences of the epidemics that were seen. The bacteria, the bacteria was discovered by this was discovered by Alexander Yersin, the plague bacteria, which is Yersinia pestis, and is carried by the rat flea. And the rat is not the only rodent. There are other rodents like the marmots which carry the Yersinia pestis, and they spread through the migration of the rat, because the fleas would infect the humans and bite them, and the plague would go. So right now the plague is sort of endemic in certain parts, and we did have a plague vaccine in India when it came to India. So this plague actually spread from China initially and spread all over the world, and it spread through the ports and finally came, to Europe in many places. And as you can see, Venice is the port where it was a flourishing city with many, the cultures, the literary people were there, the artists were there. So Venice was a very flourishing port city. So it came to Venice, and when it came to Venice, the people of Venice had this intuitive thought that we are in for a huge loss of lives. So how do we deal with it? And you'll be surprised to see what they did, almost what we did now. So this is the city of Venice, and you see what they have done is they have made a 40-day quarantine for the ships coming in, that they should not come to the main city and should be away from the main city, and they should follow a 40-day quarantine and then come in. They also made record books of patients, and then later part, there were manuscript books of remedies, recipes, and cures. So Venice was very progressive in this matter, and they could hold some part of the disease. So what kind of innovations they did was this, I would call them innovations because they had no idea of these, is to a concept of lazaretto, which is an isolation in space. And this photograph that you see below is Lazaretto Vecchio, which is a plague hospital, and Venice is all water, so the ships used to bring the patients, and they restricted the movement of people. And also that 40-day quarantine was there. They didn't know exactly why 40 days, but they guessed that 40 days would be enough. They wore protective clothing and did disinfection by vinegar. Travel ban was there for people coming from infected areas and checking their health before release. Sailors coming into the ships were interviewed, and quarantine of goods coming from outside, and officers employed for registering sick and the dead. So they were very progressive in this matter. Now they had this doctor, it's called the plague doctor. And if you can see the plague doctor, these are sketches from that century, that they had a beak mask, and that inside that beak they had herbs, so that what they're breathing is actually getting filtered. And then they had a hat, a glass spikes, a protective garment, the gloves, boots, cane, and the cane was essential to keep the patient away. So very much our PPE kit type of thing. So this was in the 14th century. Now, the medium of expression in the 14th century was mostly through writings. It was rare, but paintings, sketches, and some handwritten manuscripts which were not so well circulated. The paintings were a strong medium of communication, and because they remain, and they still speak of their precise visual language, and they are also available. We are looking at the paintings after so many years. Now, countless artists died during Black Death, and the artistic loss was huge. But what about the living? So this is a painting that you see by Peter Bruegel, A Triumph of Death, which actually shows the horror of plague. And if you look minutely in the painting, you will see what it indicates is that all members of society, whether rich, whether poor, they were all affected. So this is a very famous painting of that era. And if you look at these two paintings, that's even more interesting, that the left-hand side, God is telling the humans who's pierced with the arrows that you have sinned. So you are being punished, where dead bodies are being shifted when the priest is reading the last rites. little later, this kind of uh, impression shifted to more sympathetic compositions, where people now wanted to care for the sick and give adequate respect to the dead. So this shift was also very important, because the religious connotation of that humans have sinned and that's why God has given this disease was gradually shifting towards more compassionate outlook. So paintings played a big role in this. So at that time, Leonardo da Vinci was staying in Milan. Um, that was in the 15th century, and Milan was a very crowded city at that point, and he was working on, as great artist he was working on two twin paintings, Madonna on the Rocks, and he was totally engrossed in these paintings. But at that time, the plague hit, and what happened was Leonardo actually tried to make a design for a city which will not have narrow alleyways which are difficult to navigate and dirty and crowded, and so it's totally conducive to the spread of the disease. And this plague were actually spread by the rats. So he made a city diagram, that a network of canals that would support both commerce and sanitation, vertical division into as many as 3 different tiers, and by vertically tiering a city, Da Vinci separated areas used for commerce, transport from those used for leisure and living. So Milan underwent many changes at that time, but since it was a very old city, not huge changes could be made. So after the plague, the doctors who set aside classical texts, they also gradually turned to empirical evidence. And it was a revival of medical science in a way. And they created boards of health which were in charge of quarantine. And for the first time, hospitals split patients up into specific wards so that broken bones and wounds, they were treated separately from diseases. Previously, all patients were put together. There was also a rise in trade associations to take care of medical costs and funeral expenses. So the reshapers who came at that point of time were actually, what is said is that because of the plague, the Europe actually shifted from Middle Ages to the Renaissance. And in the Renaissance, you can see explorers like Vespucci, Columbus, Verrazano, who were trying to discover a new world. And the knowledge and art was given by Leonardo, Michelangelo. Galileo established the process of scientific method. So there was a lot of change in this reshaping, and that all happened after the plague has caused havoc over there. So but in India, when bubonic plague came in 1896, the first official case was reported by an Indian physician from a house from one of the houses in Bombay Presidency. There were a lot of people who died in India in this. So who came at that time was Hafkin. So he was a Ukrainian bacteriologist who came to Bombay and established a laboratory. Today it's called the Hafkin Institute. He began his studies with infected rats. He extracted the bacteria and successfully grew more for heat killing. He was able to conduct a few experiments with prison inmates and volunteers and demonstrated that he could reduce plague's mortality by 97%. But this vaccine was at that point of time distributed in many places, and no one really knows how many lives it actually saved. But it did not continue as plague also receded. But this was the first plague vaccine, and it is estimated that 26 million doses were sent out between 1897 and 1925. So this was done very much in India by Hafkin, who is a very well-known name. And so all this we are seeing when the germs, there was no concept of germs. Even when smallpox vaccine was being done. Nobody knew what was spreading the disease. Was it the air? Was it something else? Was it contact and all that? So two gentlemen, one was Leeuwenhoek, who discovered the microscope, looked under the microscope in water, and looked several of the organisms which he called animalcules, and Robert Hooke also developed the microscope. So then it was established that the disease could be caused by pathogens, and bacteria were seen for the first time after this. Can I have the next slide? I think the one before this? Yes. So the Spanish flu that I said, which was a huge, it happened during the World War I, and it was in 1918, which killed about 100 million people. And it came from the bird. It is thought it came from the bird. And there were other flu epidemics, like the Russian flu in 1977 and 2009, the swine flu, which was actually, it got contained, but it was quite very, very infectious and lethal. So the Spanish flu is the one to which mostly COVID-19 is compared. So if you look at COVID-19, next slide, can you give it to the next slide, please? I cannot change it from here. I know I'm pressing, but it's not working. The Spanish flu also came in three waves. So one was in early 1918, late 1918, and late 1918 again, the third wave. And it is said that the end of World War I came because the situations were such that this flu was killing in droves. And so the end of the World War I was actually forced on by the Spanish flu. And the death was maximum in the second wave. If we compare the COVID-19, you can see that the third wave is the one which infected maximum people in the US. In India, it is the third wave, and in between there were smaller waves also in Delhi as well as in the whole of India. So it is very comparable to the Spanish flu in terms of the waves. Now, if you compare this, there were about, in about 103 million people, which much less populated world, the Spanish flu killed about 675,000 deaths in the US, 50 million deaths in the whole world, and COVID-19 killed about 213,000 deaths in the US and 1.6 million in the whole world. So in terms of killing. So if you also see at that point of time, they used masks, but these masks were made of gauze, and the gauze had larger pores, so it was not very effective. But the US had the data. US had the data that those states that actually kept the social distancing in their practices, they had lesser number of cases, as you can see here with St. Louis, as compared to Philadelphia, where in Philadelphia there were long marches and gatherings that actually spread the disease and killed many people. So, but the US, when COVID-19 struck, there was so much, confusion, but they had the data from a previous pandemic. So one of the interesting things about this is this flu, since this virus was so infectious, they decided to retrieve it. And so in the Arctic, when the flu went to the Arctic, it killed about 72 people of a population of 80 in a village called Breivik Mission. And in the first attempt, they were unsuccessful in 1951 to extract the virus. But with evolution of molecular biology techniques in 1997, they were successful in actually retrieving the virus from the graves that you can see here in the Breivik Mission burial site. So John Hultin was the scientist, who went there as a PhD student, was unsuccessful. He went there again when he was 72 years old, and he gathered material which he brought in and sent it to CDC. And the H1N1 virus, was retrieved from the remains of some of the bodies. And it has a nucleoprotein core, and it has a neuroaminidase and hemagglutinin on the surface, which latches onto the host cell. And all of it actually came from the birds. So this origin of this virus was the birds, which came to humans and adapted. So from that extracts of the viruses, the sequences that they got from the Breivik mission, Peter Pallis actually used reverse genetic approaches to make virus construct, and Terence Stumpy took these viruses that were made, which were growing very fast. You can see in the right-hand side Petri plate, and they injected in the mice, and it was also very, very lethal and had similar changes in their lungs as was seen in the Spanish flu. So actually a virus was resurrected out and experimented with, but they're still working on why this was so extraordinarily infectious and killing and virulent. So that is what they're still working on. So one of the revolutions which happened with COVID-19 is the mRNA vaccines that all of you are very familiar with, where genetic sequence of the virus is used to make the synthetic mRNA sequence. And the instructions are there for making the spike protein, and the spike protein is the one which latches onto the cell. So against these spike proteins, these expressed protein, the RNA is put into little liposomal packages and sent and given to the arm, and then the immune cell sees them, and as I said, I told about the antibody making by the B cells. They again follow the mRNA code to produce the spike protein, and antibodies could be generated. So 2 people actually were recognized for this by the Lasker Award, Dr. Kathleen and Drew Weissman, for key contributions that allowed mRNA vaccines to become a reality. And these vaccines had tremendous impact reducing mortality. And mRNA vaccines are not a very powerful weapon, not only a very powerful weapon for containing SARS-CoV-2, the platform was there. mRNA vaccines were being worked upon, but COVID actually triggered its final, to make it in the final avatar and inject a large amount of populations all over the world. So this is a future for the vaccines, and there will be many diseases for which mRNA vaccines can be made. So the techniques are very well established now. The other advances that has happened is digital health that you are familiar with telehealth. The visiting of the doctor is not necessary. You can communicate on the telephone, but although it's not really the way we would like it to be, but this is going to come and this is going to happen, because if you want to avoid the patient coming into your chamber, this is going to happen. And virtual care, this will be called virtual care. The other innovations that came was improved diagnostics, ability to sequence fast, analysis of data using AI, and to generate vaccines in a short time. As I said, mRNA vaccines can be generated in a very short time, and improvement of the healthcare facilities is something that has happened over the years. So till again we are hit by a great pandemic, we don't know how ready we are, but these are the things that are happening very fast. And regarding the science of it, I think a very detailed molecular understanding of basic principles underlying the dynamics of host-pathogen interactions, as I showed you that how host-pathogen interactions are happening, is still happening in us right now, and that has to be understood in more details, because the onset, the progression, and outcome of infections is missing for many of the pathogens that we actually harbor. And fundamental questions about origin and route of infection, transmission, latency time, progression, host immunity, and defense with the changing climate, with the changing, uh, the way we travel, the way we go all around the world, everything is changing. So we need to understand that. And also the co-infections, how infection by a single pathogen affects the susceptibility to another pathogens. That is also very important. And to understand, we do not have many data about this, and how the complex interplay of play of epigenetics, environmental factors, and genetic predisposition determine pathogen susceptibility is a very important thing to work on. And factors driving the evolution of pathogens. Like, for example, we use many drugs now, and these drugs would induce mutations in the pathogens to change, and that is something that we understand incompletely. And is there a possibility that the drugs we produce will not induce mutations? So those kind of studies are really required. There's one sign of hope and great expectation is that these are the nodes which are collaborating on after COVID-19. And hopefully these interactive endeavors with interdisciplinarity coming in would solve many of our problems in future. So we know so much, yet we do not know enough. This is what it is. And also, the more we know, the more we realize how less we know. So thank you very much with that.